Welcome to the Data Hall YouTube channel. In today's video, we are going to talk about earning management. So earning management is an area that is well researched on, and within earning management, we have a specific area which is called accrual earning management. And what accrual earning management is, it contains two different types of accrual earning management. One is called discretionary accrual, and the second one is called non-discretionary accrual. So discretionary accruals are those accruals that are intentionally managed by the managers, and non-discretionary accruals are the one that results due to certain accounting procedures. Now we need to divide or disentangle these two accruals, right? So we have total accruals, and then we need to divide them into these two parts so that we can use them as a dependent or independent variable in our research. And to divide accruals, total accruals into, or to disentangle this total accrual into the discretionary and non-discretionary part, we need to use certain models. So we have these four main types of models that are used in research. We have John's model, Dechow 1995, Kasznik model, and then we have Kothari model. So what we are going to do is we are going to look into the formulas or equations of these models. We are not going to talk about the theoretical aspect of it. That is what you can cover from the research papers, and then we are going to look into how to estimate these models in Stata. So basically this is the applied side of this accrual management. How do we estimate these accrual management models? So these are the four models that I have placed them side by side so we can compare them and we can understand what are the differences in these models. Again, why are these differences there? These papers do present that theoretical justifications in the research papers, right? So first thing is, to estimate these models, we first need TA, which first thing, it is panel data. So we need information we need cross-sectional and time series data. So for each firm, we need different years of data. First, we need to calculate TA, which stands for total accruals. And to calculate total accruals, it is the difference between net income minus OCF, or cash flow from operations, right? Operating cash flows. Once we have total accruals, what we do is we divide that with the lag of assets. So if you can check this over here, this IT minus 1 stands for the lag of total assets. So this becomes the dependent variable of our, let's just say, John's model. On the independent side, we have the constant term, which is 1 divided by the lag of total assets. Again, all these variables are scaled by the lag of total asset to control for heteroscedasticity. Then the second variable is change in revenue. That is again scaled by total assets, lag of total assets. And the third variable is property, plant, and equipment, right? So what we do is we take our dependent variable, regress them on the independent variable, and the residual part of this equation would become the discretionary accruals, right? And the fitted value of this equation would become the non-discretionary accruals. And how do we do that in Stata? That is what we're also going to discuss in this video. Then Dechow model is somewhat similar. We just do the change in accounts receivable, right? REC stands for accounts receivable. So change in account receivables, those are deducted from revenues, and the rest of the equation is exactly the same. Then the third model is also somewhat same to Dechow 1995, except for we have change in cash flow from operations. And in Kothari model, if you can see in other models, they have the constant, they use the no constant. So this is a regression through origin, and this is their constant. So not exactly the regression through origin, but when you execute this you would not use the constant. So if you're using Stata, you would use the no constant option. But in Kothari, we do have a constant. This is what they have explicitly mentioned in their paper. Okay, and the additional thing is, as compared to Kasznik model, instead of CFO, we have ROA, right? So what we do is, these are the steps that we use. We select the relevant model. So first we need to decide which models we would use. Either we use John 1991 or Dechow, which is also called modified John model, etc. So once we have decided on the model, then we would calculate the variable that are used in the model. So if we decide to use John's model, then we need to calculate TA. We need to have change in revenues, we need to have PPE, etc. And then we need to estimate the regression. The residual from the regression in step 3 that we have estimated would become the measure of discretionary accrual. The fitted value would be measure of non-discretionary accrual. But do remember that there are two ways of performing this step 3. Either you perform a pooled regression, pooled OLS regression, and or what you can do is you can regress. You can do a cross-sectional regression for each year. So for each year we execute a cross-sectional regression instead of applying a regression on whole data, and then we calculate the residual, and again the residual becomes the discretionary accruals. Okay. Okay, so how do we do that in Stata? So there are multiple ways of doing that in Stata. Now you can obviously write your own do file, but what I have done is I've made an easy to use command which is called EAR_MGT. This whole thing becomes the command. This part is the command. Normally you would install the command using ssc install, but this command is not available using ssc install. What you can do is you can download it from the link given in the description of this video. Okay, so once you have written the command name, then you need to specify the variable in your data set that contains total accrual. Remember, you do not need to calculate this whole part. You just need total accruals, and the program, the command would automatically divide it by the lag of total asset, right? So you just need to provide the total accruals. You can also use if and in parameters, conditional statements. Now we have these options. So first option is we need to specify a model. So within models, we either write John's 1991, Dechow, etc. Whatever model we specify, we would have to specify the requirements for that model. For example, if we specify we want to use John's 1991, so what we do is we specify John's 1991 over here, and so this then we would have to, so in John's 1991 we have total accruals which we have already specified in the equation in the command. We need revenues and we need PPE, right? So what we need to do is there is this revenues option. So we write revenue, and within parentheses we write the name of the variable in our data set that contains the revenues. And the second thing, for John's 1991, we need property, plant, equipment. So we use the PPE option, and we specify within parentheses, we specify the name of the variable, right? The name of the variable that contains the data related to property, plant, and equipment. Okay, so let's move to Stata and see how we are going to execute this in Stata. So first thing is that when you download that command from the link given in the description of this video, what you would see is you'd be able to download this ado file. So this, what you need to do is you need to copy this ado file and paste into the directory, which is your current working directory, right? And then you would be able to use this command. Okay, so my current working directory is the earning management folder. So I'm going to set my current working directory, and then I'm going to import the data file. So within data, what we have let me show you the data. So let me sort this data on symbol and year. Okay, so we have different firms, and for each firm we have around 4 years of data. We have their property, plant and equipment, revenue, account receivable, total assets, return on assets, total accruals. Remember, this is not scaled. And then we have cash flow from operations, CFO, right? What we need to do is, first we need to XT set this data. So we need to tell Stata that this is the panel data, and within our data, this variable identifies the firm information, and this is the time variable. Normally you would have yearly data to estimate earning management values, earning management models. So XT set. Okay. Next, what we need to do is we need to let me remove all this and let me write it by myself. So we need to write the command name. You would write it exactly like this, including the underscore, right, without any spaces. This is the exact command that you're going to use. Then specify the variable that contains the information regarding total accruals. Again, this is not scaled, divided by a lag of total assets, because that is what the program would do by itself. Next, we need to specify the option, so which model we would use. So there are 4 options that we can use. So you can write either write Jones 1991 or Dechow 1995, Kasznik 1999, or Kothari 2005. Whichever model you want to use, you would have to write it in exact same manner, all small caps and without any spaces within them, right? So if you do something like this, I mean, you do not write the model that I have specified over here, or you misspell the string, then it is going to give you an error that that the option model is incorrectly specified, right? So you need to specify the correct model. So once you have let's get back to that. Once you have written the model, then what you need to do is you need to provide the specific parameters that are required by the Jones model, and I have discussed that in my presentation file. So Jones 1991 model requires that you specify the total accrual, the revenues, and PPE. Remember, you do not need to calculate the change in revenue by yourself. That is what this program would do. You just need to specify. So what we do is within the syntax, we have this revenue option, right? So we would specify a revenue, and within this revenue, we would write the name of the variable that, in this case, it happens to be exact same name, but that might not necessarily be the case in your data. The second thing that we need to specify in Jones model is the PPE, and for PPE we have this PPE option, right? So we specify PPE option again if we misspecify, or let's say if we forget to specify all the variables that are required, and we execute the model, what it is going to say is that for Jones 1991 model, you need to specify these 3 options, right? So we are going to specify PPE, and our property, plant and equipment variable is this one. And last thing it tells us to specify is total assets, because we need to scale them using total assets. So this is T asset, and this is our variable that contains the information regarding total assets, right? So once we have done that, if we execute this command, what it would do is it would generate these 2 variables, DAQ, which stands for discretionary. So its name would start with DAQ. Either it would be DAQ or NDAQ, and then the the name of the model that we have used, right? So in the description we have it's in the label we have its description. This is the discretionary accruals using John's 1991 model, and non-discretionary accrual using John's 1991 model. So that was the first thing that we have done, and let me sort that by year just so that we can see what had happened. You would see that for the first year, which is 2005, in our data set, we do not have any values for discretionary and non-discretionary accrual. That is because we are going to take lag after assets, and that would cost us 1 year of values. From 2006 and onwards, we would have discretionary and non-discretionary accrual values, right? Now remember, what it did is it executed it regressed the total accruals scaled by, obviously, all the variables scaled by total assets, and then whatever the error, whatever the residual value was, became our discretionary accrual. But most of the research would do is it would execute a cross-sectional regression. So for each year, right? So for example, for 2008, it would execute this regression, right? And then calculate the residual and so on and so forth for each year. So you can also do like for each sector and year, but in this case, I'm just going to do for each year. So this command is Bible, right? Bible means we can use by sort with this by sort prefix with this command. So that we use bys, which stands for by sort, year, and then colon, and then the same command that we already had. But one thing that you need to remember is that because when this command would be executed, let me show you the error. When this command would be executed, it is going to, because we are still using John's model, so it is going to generate this variable. So we need to first remove them, otherwise we would not be able to execute this command. So once we have executed this command, so the residual and the DAQ and NDAQ values will be different, but what it had done, it has used cross-sectional regression for each year, right? Okay, what if we specify the Dechow model, right? This model name, but we didn't. So in Dechow models, what we need is we also need account receivable, but we haven't specified the account receivable option. So what if we execute this, it is going to give us an error, and the error says that for the Dechow model, what you need to do is you need to specify all these options. So we have already specified revenue, PP, and total asset options, but we didn't specify the account receivable. So what we are going to do is we are going to write account receivable and specify the account receivable variable, right? If we execute that, again, you can do that by year, by sector year, or simply remove the prefix, and that would generate again the discretionary and non-discretionary accrual for the Dechow model. We are going to do quickly the other two models as well. We are going to use this Kasznik model, and within this Kasznik model, you would see everything is exactly the same as Dechow, but we just have additional variable as change in CFO. So what we are going to do is we have this CFO option, and we are going to specify our variable name that contains the cash flow from operations information, and also we need to change, we have already changed that, the name of the model. We execute that, we have our discretionary, non-discretionary accrual, and for the last thing, for the Kothari model, we need ROA instead of CFO, right? And we also, okay, I will come back to that constant thing in a minute. So we need ROA, and as you can see that although I am specifying the ROA option, but I am not removing the CFO, right? But that doesn't matter, because what this program would do is it would not take CFO into account, right? even if you have specified that into the command. So let's change that to Kothari, and if we execute that, and let me just show you the okay, let me just summarize this DAQ for a second, and you can see that these are the values. And what if let me drop these two and let me re-execute this, but now remove CFO, and let's see if that changes or not. And then we do sum, and you can see that whether you write those additional variables or not, the model is correctly calculated. So in previous case, we had additionally written the CFO option, although CFO option is not there in Kothari model, but the command would work perfectly fine. Now let's come to the last option that we have in our command, that is called no constant. So remember, when you do regress DV on different IVs, there is one option which is called no constant within this regression. And what this means is that you need to, so the regression would be through origin, the constant term would not be included in the regression, right? And why this is needed is because if you look at all these models except for the Kothari models, the Kothari model have its constant, but in all other three models we do not have constant. So there is a debate whether there should be a constant or not. But if you want to use these models as they were designed, with all these Johns, Dechow and Kasznik, you'd have to use this option over here, that is no constant, right? But for the Kothari model, because there is a constant, you would not have to use this option, right? So to make it simple, use the no constant option with Johns, although I didn't use it, but you should use it, except for the Kothari model, right? So I hope that was useful. Do subscribe to this channel, do hit the like button, and you can download this command from the link given in the description.